Hey class, so if you're watching this video, that means you unfortunately were not able to make it to the review session today. So sorry we missed you. It would be nice to kind of catch up and see you guys. So this is what we did today. We're reviewing, and this is solving quadratic equations. All right. So first, we're going to talk a little bit about simplifying radicals, right? Because you have to be able to simplify radicals to solve these quadratic equations. All right. So the simplified radicals, right? Remember that we always have to look for the largest perfect squares that is a factor of a number inside the radicals. Right, and these are those perfect squared numbers that we need to look for, right? 1, 4, 9, 16, 24, 36, and so on. So we're going to use this multiplication property of square roots to break up the radical, right? So we're going to take any sort of square root number, and we're going to break it up into a square root, a perfect square root times another square root, and this perfect square root is what you can simplify. Right, and that's kind of step 3 here. Right, we're going to simplify the square root of the perfect square and leave any factor that is not a perfect square inside the radical. All right, and also remember that this multiplication property of square roots works both ways, right? I can break up a radical this way, right? But I can also multiply two radicals to make it one radical and then break it up again to find that perfect square factor. All right, this is kind of like a two-way street here. All right, so the directions here say to simplify the radical expressions completely. All right, so we have that square root of 72, right, and we need to simplify that all the way simplified. All right, so to do that, right, we're going to need a calculator because we want to break up this square root of 72 into two numbers, right, two of its factors. All right, so we want this perfect square factor here times another factor of 72. So we simply take our calculator, right, and start with 72, and we start dividing it by these perfect square numbers up here, right? So what is the largest perfect square number that can divide evenly into 72, right, or that is a factor of 72? Well, I look down here, like 49 is too big, 64 is too big, so then let me try 36. All right, so we can take 72, we divide it by 36, and lo and behold, it breaks down. It is a factor, right? It divides evenly into 2. So that means we're going to take, we're at 72, and we're going to break it up into the square root of 36 times the square root of 2. And now with my square root of 36, right, that is that perfect square number. So that turns into 6, and that rad 2 just simply stays as rad 2. All right, and example 2 here, right? Now this is where I'm going to multiply these together, right? So I have a rad 7 times a rad 14, right? Those are both radicals, so I can multiply those together. So I'm going to take 7 times 14, right? And we get 98. So this turns into the square root of 98. All right, so now that I multiply together, now I want to break them apart again because I want to find the perfect square factor. Right? The square root of 7, there is no perfect square. The square root of 14, there is no perfect square. But when I put them together, now I get the square root of 98, and now I think I'm going to have a perfect square factor of 98, right? So again, I'm going to take this 98, and I'm going to divide it down the line here. All right, I want to try to find the biggest one and the largest number that can go into it evenly. All right, so 100 is too big, 81 is too big, 64 is not going to work, so I'm going to try 49. And 98 divided by 49 is 2. So that means I'm going to break up the square root of 98 into the square root of 49 times the square root of 2, because the square root of 49 is my perfect square, and that simplifies to 7, and this rad 2 stays as a rad 2, so that means my final simplified answer is 7 rad 2. All right, in example 3 here, I have 2 rad 5 times 3 rad 10. Right, in this case, I have numbers on the outside, so I'm just going to simply multiply those numbers on the outside together, right? 2 times 3 is 6. Then we have numbers on the inside, right? I mean, inside of the radical. So a rad 5 times a rad 10 is a rad 50. All right, now I have my radicals, so now I want to break up my radical into two radicals, right? A perfect square factor times another factor. All right, so I'm going to take that 50, and I'm going to see which perfect square number goes into 50, right? And I believe it's 25. So 50 divided by 25 is 2. All right, so that means I'm going to break up this rad 50 into 25 times rad 2, right? And this 6 kind of just comes down, right? And since it's all next to each other, this is all multiplication. All right, so now this rad 25 simplifies to 5. All right, this 6 stays on the outside. So now I have 6 times 5 times rad 2. Well, I could do 6 times 5, right? That gives me 30 rad 2. Awesome. All right, so now we're going to talk about the solving the quadratic equation using inverse operations or square roots. All right, so when we're doing this, right, our first step is to always isolate that quadratic term, right? And our quadratic term is either going to look like this with an x squared, or it's going to have a parentheses around it with this square, right? That little square, that little exponent of 2, makes it a quadratic term. All right, so we're going to isolate that using inverse operations. All right, and then we're going to take the square root of both sides of the equation, and don't forget that plus or minus sign, right? Because it is a quadratic, right? Because it has a degree of 2, I have 2 solutions. All right, and then we're going to simplify the radical expression and make the 2 equations, if needed, to finish solving the problem out. All right, so the directions again say to solve the following quadratic equation using inverse operations. All right, so number 4, we have x squared is equal to 12. All right, so my quadratic term is isolated, so now I'm ready to take the square root of both sides. All right, because a square root undoes a square. So we're left with x on my left equals plus or minus. Well, the square root of 12 is not a perfect square, so that means I need to break it up, right, into a perfect square factor times another number. All right, so that's square root of 12. I'm going to break up into the square root of 4 times the square root of 3. Right, because 4 times 3 is 12, and 4 is my perfect square factor. So this perfect square factor, right, simplifies to 2. So now my final solution is x is equal to plus or minus 2 rad 3. All right, and number 2 here, I had 2x squared is equal to 90, right? Well, here I have a 2 on front, so I have to get rid of that 2. And I get rid of it using inverse operations, all right? It's because it's being multiplied, the inverse operation of multiplication is division, right? So I divide both sides by 2 first. So we get x squared is equal to 45. And now I'm ready to take the square root because my x squared is related. Right, so I take the square root of both sides, and we get x is equal to plus or minus. Now this rad 45, I'm going to break up into 2 radicals. Right, and the largest perfect square factor that can divide evenly into 45. Right, it's not 16, right? Nope. And it's going to be 9. So this is going to turn into the square root of 9 times the square root of 5. With this 9 being my perfect square, so we get x is equal to plus or minus 3 rad 5. Awesome. All right, let's do a couple more. Right, again, here's those perfect square numbers, right? These are the numbers that I need to break my radicals up into. All right, so number 6 says x squared minus 2 is equal to 30. All right, so again, to isolate my quadratic term, right, I have to add 2 to both sides first. So here we get x squared is equal to 32. All right, now that it's isolated, my quadratic term is isolated. Now I'm ready to take the square root of both sides. All right, so we get x on the left equals to plus or minus. Well, the square root of 32 is not a perfect square. So I have to find the largest one that's a factor of 32. All right, so we take 32, and I'm going to divide down the line. Well, 25 is too big, so I'm going to try 16. And there it is. So I'm going to take that rad 32, and I break it up into rad 16 times rad 2, because this 16 is my perfect square. So now I have x is equal to plus or minus 4 rad 2. All right, number 7, we have x plus 2 in parentheses squared is equal to 25. All right, so now this whole thing is my quadratic term, and it is isolated. So now I'm ready to take the square root of this side. I'm ready to take the square root of that side. So when I take the square root of my left side, we get x plus 2 is equal to, well, the square root of 25, right? That's a perfect square factor, so it's just plus or minus 5. All right, now I have to finish this off. I need to make two equations, all right? So in this type of problem, when they have this parentheses with stuff inside of it, all right, I need to make my two equations here. All right, so my first equation is x plus 2 is equal to 5. And my second equation is x plus 2 is equal to negative 5. All right, and now I'm going to solve both the same way. Right, I subtract 2, I get x is equal to 3. And I subtract 2 on this one. This time I have negative 5 minus 2, and that gives me negative 7. So those are my two solutions. All right, we got two more here. All right, in example 8, right, we have 2 times x minus 3 squared is equal to 98, right? So here's my quadratic term, and I have a 2 on the outside. So I have to get rid of that 2, and I get rid of it by dividing it, right? Because it's being multiplied, then the inverse operation of multiplication is division. So now I get x minus 3 squared is equal to 49. All right, now to get rid of this square, I have to take the square root. I take the square root. All right, this square root undoes my square, and we get x minus 3 is equal to, so now I have to simplify the way of 49, right? But again, this 49 is a perfect square, so it simplifies to plus or minus 7. All right, now from here, I have to make two equations because I have a plus 7 and I have a minus 7. So I say that x minus 3 is equal to plus 7, or x minus 3 is equal to negative 7. All right, and I'm going to solve both of these the same way, right? We add 3, we add 3. So 7 plus 3 gives me 10 for one of my solutions. Then we add 3, we add 3. And we get x is equal to negative 4 for my other one, right? Because a negative 7 plus 3 is a negative 4. All right, last one here. All right, we have x minus 5 squared plus 7 is equal to 16. All right, again, it is not isolated. My quadratic term is not isolated. So I have to get it isolated by moving the 7. All right, so since this is a positive 7, I need to subtract 7 from both sides. And now we get x minus 5 squared equals, well, 16 minus 7 is 9. All right, so now my quadratic term is isolated, and now I'm going to take the square root. I'm going to take the square root. All right, and because I'm taking the square root, right, this gets rid of my square on this side, and this gives me plus or minus 3. All right, since this is a plus or minus 3 equals to x minus 5, right, this is where I need to make my two equations. So here I'm going to say that x minus 5 is equal to that positive 3, or that x minus 5 is equal to a negative 3. All right, and solve this, right? We add 5, we add 5. So here we get x is equal to 3 plus 5 is 8. All right, and we're going to do the same thing here, right? Add 5, add 5. And we get x is equal to a negative 3 plus 5 is a positive 2. And that's my two solutions. All right, so now you're ready to work on the quizzes. All right, again, if you have any questions or anything, please email me and reach out to me. Have a good weekend, and we'll be back for our last week next week.